Cool. All right. We are looking at Prettier. Uh, and this is maybe like the fourth Java, JavaScript project we've done in a row. Um, Again, I'm not a JavaScript developer. I do backend. Whoa, whoa, whoa. Um, so, um, so pretty easy to understand. What it is a code formatter. 1 second, let's make sure that this is up and running. So what do we expect to see? If it's super in depth, then maybe it will create a whole abstract syntax tree of all of the code. It's going to, tokenize parts, all of the traditional kind of compiler steps, um, and then it's going to have a way of ingesting rules about how you want to format the output, presumably, or maybe since it's opinionated, there's just one set of rules that are kind of baked in. Um, so we should expect to see a bunch of stuff that we've seen before when we've looked at compilers, um, and uh, and so that's mainly what I expect to see, but written in JavaScript, and yeah. So let's take a look. I'll also pop out this here chat. Hello, Henri. Good to see you back again. And let's keep this above all the other windows. Bonjour. Are you Henri? Are you French? Seems like a French name. Okay. Cool. So they've got a nice logo. They seem to be people who are uh, into uh, visual design. Okay, so we have types. Is types important? I think it's not. That's just a standard TypeScript thing, right? So 82% JavaScript, 5.9% TypeScript. We also have some CSS and some SCSS, which is some thingy that compiles to CSS, if I understand correctly. All right, so let's dig into source. I'm going to guess source. Whoops. Source is where it's at, not changelog. All right. We've got lots of language implementations. So I'm guessing these are, if you want to prettify JavaScript, this is where the implementation, JSON, this is where the implementation is. YAML implementation is here. I think this is just laid out by which language we're prettifying. Should we pick one? Yeah, I guess so. Let's pick YAML. YAML's pretty basic. I'm gonna guess most of the interesting stuff is main. Plugins, there may be cool plugins. Document and config, I will maybe config. Cli is maybe just a tool to invoke the functionality from the command line, and common might be important. South African, cool. That's very cool. All right. So here's language YAML. Do we want to read this first? I'm not sure. I guess we might as well. Maybe this will give us like a little bit of a taste of how some of the stuff we see next is supposed to be used. Embed, I'm going to at least quickly. Index, I'm going to guess is not interesting. This LOC is probably lines of code. We have a parser, options, pragma, print, preprocess, printer, utilities, and visitor keys. Visitor keys might just be like the visitor pattern. Is he writing YAML tooling for templating for a salt stack? Cool. I'm not familiar with salt stack. What is salt stack about? All right, so we have embed. We have this function embed, which will take a path and some options. And from the path, we're going to get, I guess, a bunch of nodes. I don't know what assigning to the curly brace syntax is. But I'm going to guess this is essentially some connection of nodes, or maybe it's a dictionary that just consists of a single node from the path. Try to format .prettier rc style rc blah, blah, as JSON first. Okay. So we're going to look at the node, and if the type is root, so I guess the node has a type, and the root of the tree or graph will have the type root as a string, or rather, uh, maybe this is not a real type. Maybe it's just a string that they've implemented their own kind of typing on. I'm not sure. Um, and if options file path, so I guess if you passed in the file path as an option, and this regex, which I guess is trying to match these files, and whatever test options is, I guess we'll see. This is like, does this, um, does the file path match this regex that's looking for these files? Then, assuming it does, we're going to return this function asynchronously, I suppose, um, which is a function that takes text to doc and returns the thing that assigns doc to awaiting on text to doc, calling text to doc on some options with the JSON parser. Otherwise, um, if we do have a doc, oh no, not otherwise, but if I guess if doc is non-null, maybe then we return um, a list of essentially like a tuple of doc and hardline. Otherwise, we return undefined. And only the root is allowed to print as JSON. We use the empty list to prevent print embedded languages traverse deep. I have no idea really what this is doing from like a design perspective. But we said embed get visitor keys to the empty list. So I guess only the root can print as JSON. So we did the root up here, and then I guess when we visit other nodes, or when we try to visit other nodes, we're going to get the empty list, and then we're going to export default embed. That's something about, I guess, formatting YAML as JSON, which makes sense because YAML's what, a subset of JSON or a superset? I forget which one. A Python-based open source software. Cool. That's awesome. All right, so index is just exporting stuff as you expect. Lock, I guess instead of lines of code, maybe this is a single line of code. So the function lock start will take a node and tell you its position start offset, and its lock end will tell you the end of the node. So I guess the node records essentially where in the code that particular node corresponds to. Then we have a parser, the function parse. We're going to call parse YAML. Parse YAML has been imported from this thing, YAML unist parser lib parse.js. Is this a thing? Seems like this is their own parser. It's in Prettier, but it's maybe in another repo. A YAML parser that produces output compatible with unist. Okay, so they're just calling some parser that I guess they wrote or modified. Then options.js is just some basically JSON. It has bracket spacing, single quotes, and prose wrap. I guess you maybe define what you want to do with brackets, what you want to do with single quotes, and what you want to do with prose wrap somewhere. I guess something like that. Based on this thing, we look at this. Here's the core options file. We have different categories: config, editor, global, other, or special. I guess config is for maybe prettifying config files. Editor is maybe for use within editors. I don't know if you can format an editor. We have a bunch of properties that define things like int boolean path string flag, which is, I guess, a type. And I guess a category is a string. I guess this is saying type is either one of these. This looks like it's defining, starting to define a syntax. A description is a string. Deprecated is a string that we don't care about. And so on. All right. So these are properties. I guess this is just documentation, right? It's not commented out like in the syntax highlighting, but I think that maybe this is just documentation. And here we have this options function. And the option has things like cursor offset, which is a special category. Its type is int, its default is -1. And this is where the cursor at the given position should move after formatting. Okay. End of line is a category global. I guess so. These categories, I guess, define like when this option, where this option is. So I guess like end of line is a global option, which end of line characters to apply. And choices are line feed, carries, return. Okay, yeah. So this is like setting options for how you want the formatting to go. Insert pragma is whatever a special is. It's a boolean that says insert format pragma into the file's first doc block comment. And I'm not sure what the format pragma is, but presumably it's some pragma that causes formatting to happen. The parser is a global that is a choice. I guess choice is, maybe if it mapped to a UI, it would have like a combo box or something, which is by default undefined in which which parser to use. And I guess these are different parsers. So I don't recognize most of these parsers, but I'm sure that they are. I'm not sure if they are developed by the Prettier people or if they are just common parser. So Babel, JavaScript. I think Babel is its own thing, right? Acorn. Let's look up Acorn parser. A small, fast JavaScript parser. So I guess, yeah. So the left are, so these are just the names of different parsers for the given language. And I guess you can just choose which one you want. And then we have plugins, which is a path. I guess a path to the plugin directory. Add a plugin. Multiple plugins can be passed as separate plugins. Okay, so this is just like command line options. Cool. All right, that was actually semi-useful. Now we're back at language YAML. And these are like just regexes for testing whether certain pragmas exist. Insert pragma, etc. Has pragma. Cool. Print preprocess. So the function preprocess, we do have an AST, an abstract syntax tree. And if you call preprocess on the abstract syntax tree, we're going to call this map node function, which I'm going to guess is essentially like mapping over a list, except it's going to map over a tree. It's going to do some sort of traversal and apply the function to every node of the tree. And the thing we're mapping is called define shortcuts. Greetings from Russia. Can you tell me what you're doing now? uh, can I translate it? I guess I can. Um, I don't know. So basically I'm building some secret stuff is what I've been telling some people. I'm working on a project that is that I'm not talking about publicly yet. So where is Russian? I don't know what the upside down smiley really is for, but yeah. All right. Um, okay. So what is define shortcuts going to do? The I don't know. It's going to take a node and switch on the type. And if it's a document node, we'll do some stuff. If it's a document body, just look at some of these types out of curiosity. Sequence item. Sequence item is maybe like an item in a list or something. Flow sequence item, I don't know what that is. Maybe like one of the branches of an if statement or something. A mapping key and mapping value. Those could be, I guess, all sorts of things. Although Maybe in YAML, um, the mapping key is the thing on the left, and colon thing on the right would be the value, and so on. Oh, I guess we are in YAML, right? So that's not just an example. That's actually what we're doing. Okay, so define shortcut takes a node and I guess the description, maybe the type of the node, or maybe the type of something, and it takes like like a function. So in this case, the shortcut maybe head is going to look at the head of the list, and the body will look at the second thing in the list. And the for a mapping value, the shortcut content will look at the children. So this is maybe just setting things up so that you don't have to like write node children 0 when you do printing. You can print head or something like that. And then printer YAML. Let's first of all, let's see if we can like find head. We do have some heads. What are some other things? Maybe head is maybe content. Print content. Yeah. So I guess this print command maybe takes what do they call it? A shortcut. All right. But let's take a look maybe at this printer. So each language, I guess, gets its own printer. And this printer seems pretty involved. We have generic print, which takes a path, options, and print. We get the node from the path. Um, the parts is the empty list for now. We check if the node type is mapping value and has leading comments. Why is that I'm not sure why that's the first thing we check. Maybe that's the first thing that happens in YAML as like the header. So if it has leading comments, then, sorry, if it's not mapping value and it does have leading comments, then onto this empty list, we push some stuff, and we are pushing uh, the uh, mapping over the path. We're mapping print over leading comments. And then joining hardline, which is maybe like new line. I don't know what hardline is. We'll look up hardline in a second. But I don't know if leading comments is something that we have here. Is that something we have here? No, maybe it's defined somewhere else. And then we go through a bunch of other stuff. So we get tag and anchor from the node. If we have a tag, we try to push print. Okay, so parts is going to keep track of essentially like it's like maybe like a work queue. And then we're going to push print tag onto the work queue. If we have a tag and an anchor, we're going to push a space. So it's tag space, I guess, anchor. That sort of thing. But let's figure out what hardline is. That's not the print for me to see kind of like how they're thinking about printing. Hardline is equal to hardline without break parent or break parent. What does it mean? Is this like whether to like break for hyphenation? I don't know what it means by break parent. Literal line without break parent. Hard, true, literal, true. So let's just try maybe prettier hardline. Oh, you're thank you. That's very kind of you. The Bionic. All right. Thanks, Henri. Thanks for stopping by. All right. I'm just I want to know what a hard line is. Let's ask Bard. All right. So in the prettier formatter code, what is a hard line? I'm guessing it's like a hard new line of some sort, but I'd like to know that that's true and that it's not something something else. It's a specific kind of line break that's okay. So it is a kind of line break that's always inserted into the formatted output, regardless of whether the code would fit on a single line or not. It is a mandatory line break that Prettier enforces. regardless of whether the code would fit on a single line or not. Okay. So if it doesn't fit on a single line, do we insert it where? Inside of the string? So it's unconditional. They are always included, even if the code could technically fit on one line. This ensures consistent formatting and readability. Oh, okay. Um, even if it could technically fit on one line. I don't know what that means. So, but I guess like if you have, I guess there's some line length implicitly or something. Take priority. They can break up expressions that would otherwise be joined together. I guess that's like hyphenating. And propagate. If a hard line was used within a nested expression, it can force line breaks in parent expressions as well. So here's an example. Hard line here, even though it could fit on the same line. Okay, so you have an array. You could imagine, I guess, having bar 2 after foo, I think is what it's saying. Comparison to soft lines. Soft lines, they might insert to improve readability, but only if necessary to prevent lines from becoming too long. Okay. So soft lines are like recommendations, and hard lines are mandatory, basically. They're implemented as a special token or object in Prettier's internal data structure. The parser recognizes hard lines in the input code and incorporates them into the formatting process. All right, great. Just basically just a hard line break. Sounds good. All right. That's enough YAML for me. Although, this is like maybe just like public types. We'll ignore that. Print preprocess we saw. Utils we saw. Visitor keys, I just want to see if this is like the visitor pattern maybe. We have visitor keys from entries. We have object.entries is set to things like root, document head, directive, alias, block, literal. So I think these are just the types of objects in YAML, and all that makes sense. Okay, here's main. And what else do we have? Plugins. I don't feel like we're going to really get the plugins. Config, I feel like we're mostly not going to. But what is searcher? Searcher, names, filter, stop, directory, cache. So this is searching for something, search in directory. This is some way to search for stuff. And then common, let's just see. We have things like AST path. Let's look at that, I guess. Common options we may have looked at. We looked at something options related, or maybe this is just the file to evaluate the command line options. Get file info. I don't think we care about that. Errors we don't care about. End of line is presumably something about end of lines, and errors we were going to ignore. So that just leaves us with main, which is what I wanted. All right, let's close the other stuff. All right. So core is probably important. AST to doc is probably not so important. Get cursor node. Maybe the node at cursor, I assume. Massage AST. That's presumably kind of fixing up the AST somehow. Parse is probably the thing that's going to invoke parsing, but we've seen that you can configure the parser. So I'm going to guess parse is just delegating to some other parser rather than being an implementation of a parser itself. Range util is maybe line, like the a selection of a line of code. Support maybe is just how to get support. Get support info. Strings and plugins are handled by a wrapped version of this functionality by with plugins. Don't pass them directly here. Collect parsers from languages. Maybe this is, I don't know what this is doing, but it doesn't seem to be like contact information. Maybe this is for if you need support, it's gathering things like what parsers you're using or something like that. At any rate, we're going to ignore it. Let's look at core.js. How big are we? 301 lines of code. Cool. That's small. And we're importing a bunch of stuff. This seems to be all pretty well laid out, modularized. Bomb is defined to be equal to this thing. Cursor is defined to be a symbol cursor. B of something. Beginning of manifest, beginning of something. I don't know. All right. We have this core format. So it's going to be async. I'm going to guess lots of stuff is async. That way we can use like essentially concurrency to in parsing. Makes sense? So core format, this should be, I guess, formatting as opposed to parsing, right? So we have the original text, some options, and add alignment size. Why is add alignment size not an option? I don't know. Is this something we call recursively, perhaps? If original text, we don't have the original text, or its length is 0 after we get rid of the white space, then it's formatted as the empty string. So the thing that we're returning has a formatted keyword as well as a cursor offset. I guess the cursor offset is where, as we saw before, where we put the cursor after we're done. So I guess if we're like here, well, there's no cursor here. So I guess we like start here. Basically where we were before, or the space right before it, I guess. And then comments is the empty list. So we have no comments. Maybe there's like running commentary for other things. So otherwise, if we're not just some fancy version of the empty string, then we call parse text, which we got from parse.js on the original text and the ops. So we're ignoring add alignment size. The parser doesn't care about add alignment size. I guess really only the formatter does. And so we get an AST, the abstract syntax tree, and we get text. I don't know if the text is formatted at this point, or what, why we need to return it back. Some version of the text. Then we check if the cursor offset that we pass in the options is bigger than or equal to 0. If it is, then we get the cursor node given the AST and the options. And so I'm guessing get cursor node is going to look in the options for the cursor offset. Otherwise, I'm not sure why we would have this guard here. But this is presumably going to say, so you can say, I guess, I want to print the thing that's like 16 characters away from where the cursor currently is. And I guess this like we'll get that node. And it's adding it to options. And then doc will be the result of print AST to doc, where we do add alignment size. I'm not sure what doc is, maybe documentation. And if add alignment size is bigger than 0, we're going to add a hard line to make the indents take effect. Otherwise, it'll be removed later. Okay, so I think this probably is documentation, and what they're doing is like aligning the documentation maybe at a specific offset. So that is obvious that is documentation. Just a guess, maybe about 60%. Sure, I could be pretty ready to find out that assumption is wrong, but that's what we'll go with for now. And then we'll set the result to print doc to string without normalized options of the doc. All right, and then down here we're going to remove extra leading indentation as well as the added indentation after last new line. Remove extra leading indentation. So if we've, whoops, no. If we're writing the style that's, if we're writing a language that's not like Python where indentation has semantic meaning, then we could in theory have like added a billion tabs, and we're going to just remove those so that we have a sane number, I suppose, by essentially calling some trim and then doing some other stuff. And then comments we're getting the symbol for comments. So maybe this is just the delimiter for what a comment is. I'm not sure. And if cursor offset is bigger than or equal to 0, then we are getting the old cursor node start and text. And whatever this is, cursor offset relative to old cursor node. We're doing some cursor monkeying around. Yeah, I'm not sure. So log start of the cursor node, that's the old one. We're getting a text slice from where the node starts, presumably to the end. Yeah, to the end here. That's the slice of text that's from the start of the cursor to however long we said we wanted it to be. Or actually, rather, however long the node is. And then we're just setting the new start, calculating the new start or whatever. And that's stuff we can skip. Diff old and new cursor node text with a special cursor symbol inserted to find out where it moves to. Okay, so if we change where the cursor is, I guess, then we're going to take the diff between the two node texts. Or rather, I think that what's going on is yes, maybe I shouldn't have skipped this. So at least for the at least for understanding the examples below, I was thinking there's some formatted stuff. Okay, so if we're down here, we have old cursor text is equal to new cursor code node text. If the two texts are equal after we've monkeyed about with cursors, then we set formatted to result dot formatted. But I don't know where we set result. We use the result of result, use the start thing here. I'm not sure if we've assigned to result yet. At any rate, I think that what's going on ultimately is that as we're changing things around and formatting, the same text gets its position changes, right? And so we're accounting for those sorts of things, I think is what's going on. So we diff the old and new texts with a special cursor symbol inserted to find out where it moves to. So how do we know? So the cursor used to be at the start of, line 14 in the old text, but I removed a bunch of junk and now it's on line 12. So we need to know where did it jump to. And I think that what this is saying is that to find that out, we're just going to do a diff. And given the result of that diff, we'll have some special character that tells us this symbol means that the cursor moved from here to here, or where the cursor is now here, or whatever. So old cursor node char array, I guess, is an array of cursor nodes, or an array of node. I don't know what the array part is, but this is where the old cursor was essentially in the node, or at least the node where the old cursor was. We're going to get that by taking the text that we got from the node where the cursor started at, I think is what this was, and split it at the split it at the empty string. And that will give us this node char array. I guess the reason it's an array is because we split the string into like individual characters. And then we're going to take that thing, the split thing, and we're going to splice it, which I assume is kind of like the inverse of split. And splice it with what? We're going to pass in the cursor offset relative to old cursor. So in my example that I think I just made up, we were at 14 and we ended up at 12 or something. So that's an offset of, I guess, -2. So we pass that in, whatever 0 is in cursor. So we say that we have moved the cursor -2 or something like that. And then we do the new cursor code array by taking the new cursor text, splitting it, getting an array of different characters. And then we call diff arrays, which presumably is just going to walk over the arrays, compute their difference, and maybe return an array, or maybe return some sort of distance function of two arrays. That's cursor node diff. Yeah, it's some sort of list or array because we're going to iterate over it. So we set the cursor offset to new cursor node start, then iterate over the diffs. And if the thing was removed, I guess diff arrays is kind of like prettier aware, so it knows, um, or maybe not. I guess any diff can know whether an item was removed. So if the thing was removed, which when you diff two files, you can there's like there's like special syntax, right, that tells you whether something was added or removed or whatever. Um, then we check if the entry value includes cursor. And if it does, we break. I guess we're done. Otherwise, we increment the cursor offset by by whatever the entry count is. I guess the entry might say like 14 lines were. I already used 14. The entry count might say like 3 lines were added, right? And so we offset by 3 or whatever. All right, and then after all that, we set formatted to the result.formatted. Whatever cursor offset was, I guess this is the thing that we computed at the end, and comments. What I don't know is where was result assigned to? It was assigned to print docstring without normalization. Is that the only time we assigned it? Yeah, I'm not sure. Okay, so it's this print doc function. So maybe we do have to look at doc, unless this was all doc related. All right, well, we'll take a peek at doc in a bit. Okay, so that's the formatting function. Essentially, we print some stuff. We check what changed, return the formatted text, return like how the cursor has changed, so that we know which text in the new version is the same as the text in the previous version. Format range takes original text and ops, and I'm guessing this is going to format a range of text. What is this called? Just format, core format. I'm going to guess this just calls out the core format. See if we can highlight core format. Yeah. So we get an AST, we get the range start and end, do some indexing, figuring out where things are, and then call core format of the range string, which I'm going to guess is just the string, yeah, the slice in the range, the text in the range, with I guess the options maybe that were passed in, together with setting that the new range start is 0, the range end is positive infinity. So from the beginning of the range to infinity, at some point, infinity will be larger than the actual range, so that won't matter. And then we're going to track the cursor offset only if it's within our range. So we do some cursor arithmetic. And then we get some result back. Since the range contracts to avoid trailing white space, we need to remove the new line that was inserted by the format call. Okay, so we trim the end, do some more calculation, I guess, and blah, blah, blah. I'm going to skip over that and see what else we can see. Normalize inputs and options that might be interesting, but I'll ignore it. Has pragma. This is just checking if something has pragma. We saw some regexes for checking if a pragma exists. Here's parse, which is not the same as the parse that's in like parse.js. The parse will take original text and some options and some dev options, maybe for development mode. And it's going to normalize input and options, and then call parse text. And if dev options, preprocess for print, we're going to call prepare for print. And if massage, we're going to call massage AST, return parse. Maybe dev options are options for developers of Prettier. Like maybe that's like versions of this function they can call that are not maybe of interest to end users. Format AST will normalize the options, print the ST to doc, and then print doc string without normalize options. Okay, so this print AST to doc, whatever doc is, it does seem to be important. And then format doc causes print doc to debug. And format with cursor. I'm not sure what that is. Print to doc normalizes, parses the text, and then prints the AST to doc. So it seems like all the cool stuff is in print AST to doc, which is here. take an abstract syntax tree and recursively converts it to a document, which is a series of printing primitives. Okay, so for them, a document is a series of printing primitives, which I'm not sure if that's the same as we saw before that like we had this list and we were pushing onto the list various print statements. So I wonder if that's what they mean by a doc. This is done by descending down the AST recursively. The recursion involves two functions that call each other. Main print, which is defined as an inner function here, it is basically takes care of node caching. Okay, so we don't keep, I guess, print nodes we've seen, perhaps. Call plugin print function, which checks for some options and ultimately calls the print function provided by the plugin. So the plugin, I guess, we saw like the YAML had this big long print function. The plugin will call main print again for child nodes of the current node. Main print will do its housekeeping, then call the plugin function again, and so on. Okay, so it's got this like mutual recursion thing going on. All the while, these functions pass a path variable around, which is a stack-like data structure, AST path, that maintains the current state of the recursion. All right. It is called path because it represents the path to the current node through the abstract syntax tree. All right. That is great. So cache is just some map. Path is a new AST path of the AST. And I think we're just basically going to do what they said we're going to do. Only the root call of the print method is awaited. So we have this call plugin print function and set it to doc. We pass it the path options main print undefined and embeds. So I guess this is the main call, right? Because we get doc and we ensure all comments are printed. And we return. Then here's main print. Main print has a selector and some args. If the selector is undefined or the selector is equal to path, then we call main print internal with the args. If the selector is an array, then we return, I guess we take path and on it we call a function, which is main print internal with the selector. And if it's not an array, then we do the same thing except we don't have the dot 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 notation. And then main print internal calls ensure printing node. Maybe there are some nodes that are not printing in the sense that they aren't visually interesting to humans or whatever. Then so we, I guess, check that this path is something we want to print so we don't waste time or resources. Then we get from the path, we get the node that it names, which we call value. If it's undefined or whatever, we return the empty string. There's nothing to print. Although I guess there is something to print, namely the empty string. And if we should cache, or rather, this is not if we should cache, this is should we cache, I guess. And that is if we have a value and the type of value is object and the args are undefined. So I guess if we, and the args are undefined, then we should cache. I guess if the args are defined, maybe we've already cached. If we should cache and cache has a value, then we return the result of the value from the cache. So this is basically just memoization. Otherwise, we call do plugin print function, which is the print function defined by the plugin, like we saw the YAML example with all of the arguments. No. What's it called? Plugin print function. I think this is where we are. And we get back to the doc. If we should cache, we set the document to the value and return doc. So I guess if I'm understanding the recursion correctly, then this is the subtree for the doc. I think is maybe the subtree of everything, like the thing and everything underneath it, and that's what we cache. At any rate, we return doc. And then we have this call plugin function. which is just going to call the plugin function, presumably. And then we prepare print that has an AST and some options. And we may have comments. And we set, I guess, set these symbols and tokens and stuff from whatever is passed into the options. And then we attach comments. I'm not really sure what that means, but somehow we're adding, I guess, comments to the AST. And then we have this printer, which just has this preprocess thing. And if preprocess is a thing, then we await calling preprocess on the AST and the options. Otherwise, we just get the AST and we return the AST and the comments. I'm not. I'm a little bit confused by how they handle comments, like why they're special case the way they are. But um, I'm not sure if those are the code comments or if I guess we saw. Yeah, so we saw in maybe core.js or whatever that I think the comments are supposed to be uh, uh, Prettier makes comments maybe about its parsing, like maybe things to log, like linting type issues that it wants to tell you about, perhaps. Here's AST path, and I'm gonna just quickly glance at this. This is some just tree stuff that is probably pretty straightforward. We have call that takes the callback and some names, temporarily push properties named by string arguments given after the callback function onto the stack. Then call the callback with reference to this modified AST path object. The stack will be restored to its original state after the callback is finished. So it is probably a mistake to retain a reference to the path. Okay, so and we have this each one. So this is all like doing traversal. I'm not sure whether we've got this mutual recursion thing. This is all pretty interesting if you are learning algorithms. That's probably a good file to check out. But we've seen it enough time, and we are sufficiently out of time that I'm not going to dig in any further. Get cursor node is presumably just going to get the node at the cursor. We give it an AST and options. We call create get visitor keys for functions with some options. And then node contains cursor is a function that takes a node and it returns whether the cursor is inside of the start and end of the text location. So I guess we're just going to essentially map this function over all the nodes to find out what the node is. So for everything at least over its descendants, and the filter is node contains cursor. Okay, so yeah, that is what we're doing. So we're just checking, we're just iterating over the nodes. We don't have some structure that makes this easier. We're literally just iterating over everything that could possibly contain it. Okay, and then massage AST is interestingly named, so I'm just kind of curious what it's up to. We've got a printer, a massage AST node, and get visitor keys, and those we're getting from the options. And if we don't have a clean function, we're just going to return the AST. So I guess you have to pass in a clean function. And maybe since you can just pass in any clean function you want, this is not so interesting because it's pretty unconstrained. So we're going to get the visitor keys, ignored properties, and we're going to return recurse on the AST. And recurse is going to what? Possibly just bail out if stuff is null. If the original is an array, we're going to map recurse over the children essentially, and possibly clone some stuff. And essentially, this is just like recursing over the tree. And eventually, I guess we call clean function here. Result equals clean function of original cloned parent. Okay, and so presumably this is used somehow to modify ASTs in ways that are useful for the parser and the printing. Range util, I'm going to ignore. which leaves us just with parser, with parse.js. And I claimed that this was not actually going to parse in the sense of implement a parser. And that does look to be the case. So parse is going to take original text and options, and then we'll call resolve parser on the options. So in the options, you tell it what parser you want to use. So I forget the name of, of any of the parsers, but you can use like the Angular parser, I think it said. And we'll get that parser. Then we'll call parser preprocess. And possibly it will preprocess, or possibly we will not preprocess. And then we're going to try to assign AST to the result of parsing from the parser, given the text and the options. And we're going to maybe handle an error. Then if we have no error, we're going to return the text and the AST, which I thought was the opposite of what happened in the other file. I thought the opposite was AST comma text, but maybe that's not right. And where is text? So text is the preprocessed text. Okay, so that's why we're returning it. It's not literally the original text. It's just we've applied a preprocessor. But now I really want to look at core, because I could have sworn that it was the other way. Okay, this is parse. I think the function I was looking at was up here, right? And parse text. So parse text returns AST comma text, but parse returns text comma AST. Where's parse text? Parse text is in parse. Is it? So we're importing parse text from .parse.js, which I think is the file I have opened elsewhere. Let's just try searching for parse text. What is going on? I feel like let's see. Let's look at blame. So parse is from last year. What about this called this import of parse text? Or maybe there's a, well, if it was redefined somewhere, shouldn't it show up in search? Where's blame? Probably just missing something fundamental. Parse text is from the same thing. So it looks like we deleted the import of parse from parser.js and replaced it with importing parse without the curly braces. That's in multi-parser. Where's core? We deleted the import of parse as parse text by importing parse text from parse.js. Yeah. And here's parse.js. We've added a bunch of stuff. Did we delete anything? What was here? Where were we importing from before? We were importing from the same file, parse.js. And here is the function that looks pretty much the same. I don't know what's going on. Resolve parser. So from this parse.js, we're in main core. So dot slash should be main slash parse.js, right? So what was this before? This looks like it's basically just a new file. Can I look at it? Can I look at it at this commit? Yeah, fix plugin resolve logic. Okay. So what was it doing before? Take a look at its history. It looks like this is the first version of the file, I think. How are we importing it before? Fix plugin result. Is there a code comment? I don't know if this is so important, but it seems a little bit mysterious to me that it seems like we're doing something that we shouldn't be doing. Here's the files changed. I guess these could be different commits on the same whatchamacallit, uh, pull request. I don't want to do code review, but let's look at this file in this commit. It does not belong to any branch. Okay, well, whatever. Maybe I got live grep up and running, so let's see if we can find any existing parse text. So we do the import of parse text, and we await parse text, and it doesn't seem like parse text is ever defined. So I'm not sure what's going on. I'm not sure if you use Prettier and you know how that works. Let me know, or it might be just broken. Is there a CI? Prod and dev. Okay, well, something's going on, and maybe I'm just not understanding. But that's Prettier. That was pretty cool. That's all for me. I'll be back tomorrow. I don't even remember what I'm looking at tomorrow, but I'll be doing 2 more of these, and 2 more each weekday for the rest of the week. So hope to see you there. Thanks for watching.